This will talk about how financing can work for energy storage projects in real case scenarios. Our speakers for this session are Mr. Vinayak Valambe. Vinayak is the Director of Financial Services at Customized Energy Solutions. He is a chartered financial analyst with extensive experience in power sector. Previously, he had done research in non-linear control systems where he worked on problems involving differential geometry and bifurcation theory. Can we please have Mr. Vinayak Valambe on the stage? Mr. C. Kannan couldn't join us for last minute appointments. In place of him, Mr. Sanjay Mathur is here with us, who's Manager Finance for Solar Energy Corporation of India. Next we have Mr. Ashish Kulkarni. Ashish has over 14 years experience in clean energy technologies, sustainability and environment management across combination of policies, regulations, consulting, financing and implementation. And lastly, but not least, we have with us Mr. Rajshekhar B. Rajshekhar is presently associated with ILFS as Head Wind Service and Chief Technology Officer, Renewable Investments. Before joining, he worked with Akikona Energy and GL Garrett Hassan, one of the world's largest independent renewable energy consultancy, as the country manager for India. I'm sorry, that was not the last speaker for the day. We also have Mr. Pramod Kulkarni with us, Senior Consultant at Customized Energy Solutions. The moderator for this section is Mr. Vinayak Valambe. I'll just hand over the mic to Vinayak.
Thank you. In the last couple of days, we have covered many different aspects. We have talked about technology. We have talked about different applications. We have looked at different case studies. So we know that stuff works. Many different technologies, they do work. There are real life examples of commercially proven technologies. However, it always comes to what it costs and how do we really finance these projects. And then many of these companies, technology developers, entrepreneurs are at the mercy of the banks. And people don't always have good opinions about bankers. So this session, we hope to throw some light from a banker's perspective and also look at different ways that things have happened internationally. And we'll see if there could be a business model that is valid for India. So what I will do is, I'll just quickly show you, maybe in 5 minutes, that how things have happened in the US and how the financing has progressed. And then we will start the panel discussion. So, in US, and this is a little bit older, so now the capacity under construction is a lot bigger than that. But mainly there are different ownership models. One is third party owned, which is more like an IPP model, or even technology developers who demonstrate the project, they own certain projects. Then utility owned projects, and then customer owned. Companies like Walmart, they have at their premises storage for different needs. But the majority of chunk is really third party owned projects. Now, how they have been financed so far, you can see this sliver, which is 31%, is through government funding. The other one, although it says project finance, that's a little bit misleading, because there are only few projects, although in terms of megawatts, there are still around 60 megawatts or so. Right? They have been financed through wind. So they could get a benefit of investment tax credits that were available at the time. And then there are other funding owners' equity. These are mainly technology developers. They're 100% equity finance. And then vendor financing. That is, there are many international companies are interested in providing. We did some quick survey of different stakeholders and see, are there any trends in financing that we see? And variety of people participated, starting from developers, technology developers, investors. So we asked them what has driven the financing or deployment so far. And answer overwhelmingly, and we gave them multiple options to select, so that's why it doesn't add up to 100% all the time. But it clearly shows that first, government had stepped in US in form of grants or loans and benefits. Then we asked them, is there any trend? Do you see project financing happening? And the answer was again, yes. The majority of people say, yes, the project financing is the way to go. And these are a little bit older numbers, but some of you probably already know, but California has made a big push for utility contract with the projects. And one of the panelists will talk about it. But these are very long-term contracts. And those are the kind of projects or contracts will really drive the deployment in large scale. Then the other things are like, what sort of capital structure do we see? But it looks like you can also have like 70-30 debt equity, that kind of capital structure, which is really for proven technologies. Then, out of different capacity that is coming up, do we see any major shift? Whether utility will just start owning the project in a big way, and it looks like it's still IPP kind of model will prevail more because it brings out the cost competitive nature in the market. Even now, the space is getting crowded in US. One of the problems that this market is facing. So, if you look at US market, recently there was a regulation, it's called pay for performance, which is for frequency regulation or ancillary services, or frequency support as we call it here. But that has driven a deployment in many places. But the issue is they are still merchant plans. So it's difficult to actually get them project financed. And there are not only long-term hedges that you can get for such a project. It has started happening. Just a couple projects that we can have some medium-term hedge in place, which helps them finance. But it's otherwise difficult to get the hedge without the utility long-term contract that we talked about. The other one is interest. This is not very meaningful because the participants were at the different regions. But something for US, I would say 6 to 8% kind of interest you will see. So what really they showed was project financing will become a major source of financing because of this utility long-term contracting. Technology risk is reducing because many are now commercially proven, they are in operation for some time, so bankers are getting comfortable to that. Capital costs have come down, so project now see desired IRR or returns that equity holders expect. And that would really trigger the large-scale deployment. And I mean, in each technology, there is a tipping point when you really see a large-scale deployment. And for advanced markets, the tipping point could be near, and California has demonstrated that. Merchant plans will be lesser and lesser. vendor financing, again, this is becoming competitive market, although it's still not like commoditized like solar PV. But all these technologies are bringing financing with them, or the long-term service contracts with them, to differentiate themselves for their customers. And the main thing is utilities will still hold the key, because they will be the off-taker of such a long-term contracts. So we will see, the verdict is not out there. So with that, I think I will throw it for the panelists for the questions. So what I request the panelists that if in a minute or two you can just introduce yourself and the company, and then we will go through question and answers, and also like audience to participate. So we will have a lot more interactive session like that. Thank you.
Okay, thanks. I work with customization solutions. I worked for the last 2 years in the enabling technologies group within customization solutions. So prior to joining customization solutions, for 22 years, I worked for California Energy Commission, which is a policy and program body in California. It's a government agency. However, we also had RD&D fund for $90 billion or so. Okay, about 3 years ago, now we have $150 million. I should say we, they, because I don't work quite very well. Nonetheless, that was a good amount of money. So over the last 20 years, I've been involved with funding early stage technology development, then demonstrations, and then eventually commercialization, or starting with companies such as photovoltaics, windmills, whole host of energy efficiency technologies, and also energy storage, starting back in 1990, which got better momentum in last 10 or 15 years. So that's a big background I think in terms of financing technologies, depending on what stage of development they are at. Because over the years as the technology matures, but not fully commercialized, the role this agency has played has varied, depending on where the scale of development that particular technology is. And I think hopefully I would like to get to share that later.
Good afternoon, everybody. I'm Sanjay Mathur. I'm from Solar Energy Corporation of India. It's a public sector enterprise under the Ministry of New and Renewable Energy. And we have a broad mandate of solar energy. We are the implementation and facilitation arm of MNRE, and we are implementing various activities under the Jawaharlal Nehru Solar Mission. So broadly, we have taken up 750 megawatts of grids connected solar power projects in batch 2 phase 1, and they are under the advanced stage of implementation, and power will flow in next 3-4 months. Another 2000 megawatts of is in the pipeline, and we'll come out with tenders very soon. We are also setting up solar parks. Recently, in the recent budget, the minister has announced support of 4,000 crores for setting up solar parks. It will support around 20,000 megawatts of capacities, and we are setting up solar plants in Telangana, Andhra, Madhya Pradesh and other states. And apart from that, we are also doing rooftop schemes. 76 megawatts is under implementation. We have already implemented 10 megawatts. We are also mandated for implementing the grid connected solar power projects, including using hybrid technologies like battery storages. We are also implementing CSP pilot projects, aggregating capacity of 100 megawatts, and this will be a 3-hour storage project using molten salt technology. And we will also be doing R&D and other solar resource assessment.
Hi everybody, good afternoon. I'm Ashish Kulkarni. I'm leading India business activities for Ricardo AEA. Ricardo AEA is international energy and environment consultancy, which is into various sectors like Ricardo, which is again a technology company which has 100 years of experience in designing and modeling transmission systems for in the automobile sector as well as in the conventional power. We've done a lot of consultancies and also in the specifically with relation to energy storage, where there's a 150 kilowatt plug and play system, and we recently won the rail industry award for innovation in regenerative braking by digital flywheel technologies, which was introduced recently in the UK. Having said that, I think
Thanks, Raj Rajshekar from ILFS Energy. I'm part of the ILFS group, which is a financial institution. ILFS Energy is the energy vertical where we are investors in energy projects, not financial. But I will be speaking about the issues because we are looking at this area with interest as to how this space is going to pan out. As far as ILFS Energy goes, we have nearly 14 gigawatts of coal, gas, wind and solar and biomass projects at the various stages of development or in operation. In the renewables, ILFS Energy is very bullish. So we have just taken the baby steps in solar, but we have huge plans. We are also probably one of the top wind IPP operators in India across 7 states. The interest for us is in trying to see how these projects, which are with energy storage, could be looked into the energy spectrum and how they could be financed. We have been backing at it for the last 14-15 months. So we'll be glad to share views with other distinguished, experienced professionals on stage. Thank you.
Thank you. So I guess I will first take up on Sanjay. So you mentioned different activities of SECI and also involves storage. Can you elaborate a little bit in terms of how the funding is available? I think there are some grants that are available, and as well as there are big grid scale projects as well as even off grid. So if you can just throw some light on that.
I'll share my experience. We are implementing one project in Gaza, and we have already tied up with the Himachal Pradesh Power Corporation Limited for that project. So we have requested MNRE to give us 50% subsidy for that. That will be a grid connected battery storage solution. It will be of 2.5 megawatt size, and we intend to scale up within 6 billions. And we have requested Ministry to give 50% subsidy for that project, so that it's a one of kind to be implemented in India. And then rest will be funded through debt and equity that will be raised from domestic markets and equity. We and HVCC will be investing.
And this will be put out to tenders, I believe.
Yeah.
Many of the technology companies in the audience, they can participate.
Yeah. Yes. Okay. It will be an open tender.
What about the off grid or small microgrid or those kind of projects?
We have been implementing various off-grid schemes. We have tendered out 100 kilowatt systems in of mini microgrid at Haryana, and it will. We hope that it will be soon implemented. Apart from that, we have done some solar streetlight projects in Jharkhand, and it was a good experience. And we intend to do more such projects by using the CSR funds of public sector enterprises. In Jharkhand, PFC had funded us for that project, and apart from that, we are also doing some solar lantern projects, and REC has funded us for that project.
And these have some batteries, like lithium ion.
Yeah, they have the battery because the
for those who may not know, so under CSR or corporate social responsibility, there is a regulation in place that certain percent, I think it's 2%,
2%.
of the profits needs to be allocated for the social projects, and these projects are qualified under that. So many these IT companies in India or many other bigger manufacturing companies in India, they have funds for such a project to invest, and that could drive the market. And we will look at later on if there is time, if there is really indeed enforced. But now I'll move on to Ashish. And we will differentiate a little bit in terms of project financing and then corporate financing or for the companies. So in terms of project financing, can you talk a little bit what are the bottlenecks or how it has happened in other places, and do you see something like that happening? And the second part is on the company side, and when we were talking about, you mentioned a couple companies. So they have certain business models in US or other parts of the world, which is working better than any other business models. Do you see something similar happening in India?
Yeah, so I'll start with what's happening outside. I mean, the energy storage is not a new subject. There have been a lot of research and development happening to some extent in the lithium ion and the batteries. It's reached to a certain stage wherein now the financing is flowing. So, I mean, to just give you an example, there's a company called STEM in the US which has raised around $100 million US, and there is Green Channel Network which has raised $10 million US recently. There is Solar Grid Storage which has again is in the process of raising $50 million US, and there is Primus Power which has got 20 million funding from venture capital. And venture capital is one space which gets into something only when they see that this has been commercialized and there's a lot of increased profitability in this space. So that's when I think there is, and if you talk about models which are working in the US, there is the leasing model is the third-party owned model, which Vinayak is become rage in the US. It all started from a small venture capital funded company called Solar City, which actually started with solar rooftop and then moved on to join hands recently with Tesla energy storage so that they can provide a combined solution to them. And instead of paying a high upfront cost, they have signed a contract for 10 years, and there is something called easy monthly installment. And Tesla is going huge into energy storage. They're planning raising funds of $5 billion US, and it's only to set up factory and manufacturing capability for lithium ion. And the whole thing about financing is you need to have a reliable product, A, reliable product, B, there should be scale, and the third is basically if the costs are too high, you need some innovative model. And there's something called LOPA, which is a term which is being used in the US nowadays. It's basically loan and power purchase agreement. So since solar has become well known and banks know about solar as of today, the solar panels and the systems components with regards to solar that can be provided, that can be just loaned out from the bank. And for the energy storage, which is still new for the banks, on the financing side, you have a power purchase agreement with the service provider, so that at the upfront from the bank, the service provider does get money basis, he recovers whatever he has spent on the energy storage. So this kind of combination is something which we can think of. And India is not new to all these kinds of financing models. They have done, if you see, solar water heaters has become a very successful thing. Or banks are providing loans for that, and SIDBI has come out with the energy efficiency related product, which is not known to many, but specifically goes for small scale industries. They are trying to do anything in energy efficiency, and it covers energy storage also. And there is a separate line from IFC and the IDFC and the World Bank. IDFC is not the Indian IDFC, but it's the International Development Bank. And there are lines created which specifically address these barriers of financing for Indian industries as well as commercial establishments. The need, I think, is for more mainstreaming the available channels of financing in India.
So we covered a breadth of things. For those who may not know, so some of the companies that you mentioned, like Solar City and SEM, what they have is a service model. So they don't really charge their customers upfront, but they either share the savings that customer is making. So for example, Solar City will put a rooftop on, and then customer, because of that, may save on their demand charge or the energy charge. And if there is a saving, they share a significant portion of it. That's how they get paid. Or they can simply have a lease on the equipment, so the customer pays over time rather than upfront. It hasn't really worked on bigger scale, like on the grid scale storage, but there are companies who are interested in such models. Going to ILFS, Rajshekhar, another thing that we have seen, to finance anything, there needs to be a clear economic case. What we have seen so far is, one is where there is heavy diesel usage, there is some economic case for energy storage. Another one could be for wind farms. So I don't know if this particular issue is with your wind farms, but I think many wind farms in Tamil Nadu have a significant curtailment. The 15 to 20% output gets curtailed. So that's a significant loss of revenue. And we have looked at some of these wind farms and have done some studies. So 10 energy storage here to capture the power that goes waste now. So do you see wind integrated storage has a better chance of financing? One, because it solves some of the issues. It also provides the firm power. So one can have a contract with commercial or industrial customers, which may benefit because now they are getting firm power at whenever they want, and they may be willing to pay more for it. Do you see such scenario? Is it easier, or how difficult it is? Are there regulatory bottlenecks for such things?
Thanks, Mike. Now, short answer, the long story to follow is yes, it is a viable thing. So we have been looking at a very small project that we had in the state of Andhra Pradesh, formerly Andhra Pradesh and also now Andhra Pradesh, in a district called Anantapur. This is a 6.5 megawatt wind farm, which is going to be completing 20 years by middle of next year. Now, this has got very small 250 kilowatt machines of 26 turbines. And what we were trying to do is, how is it that we could be extracting a higher value for the energy that is being generated? So we were looking at various combinations in first trying to, that's how ILFS ended up looking into energy storage. So first we looked at whether we could be working coupling that with fuel cells, because it is the fastest response technology, energy generating technology that we know. And thereafter came about looking at how energy, the modern electrochemical batteries could be working at. There is a case for that in terms of trying to make in the arbitrage of time shift of generation. So, for example, on a very broad macro level, in the financial year 13-14, in the zone 1 of the southern grid, where Andhra Pradesh falls in, nearly 525 million units were sold last year on the energy exchanges, with a cost in excess of 9 billion. This was in FY 13-14. So that coupled with the feed-in tariff that we get for the PPA that has been signed is around 330 or so, plus minus 10%. So what is the arbitrage that we could do? Now, we tried to investigate from there how energy storage could be adding value. And now I need to be speaking about broadly about energy storage. Currently, the costs that are there, just the cost part, whether it is lithium ion or molten salt or flow battery or any of the chemical variants of lithium ion, the costs are too exorbitant. If we are able to add the incremental cost through energy storage of the order of 6 to 8 rupees, then there is a play. Currently, the differential costs are pretty high, and it's important to understand that nearly 40% of this incremental cost to energy storage technology is just the interest cost. The capex of energy storage is pretty high, so interest costs are very high. That's part one of the issue. The second part of the issue is the mismatch of the times of the asset life of your generating things and of your batteries. The battery's life today, as what is proven and demonstrated, extends to something like 4,500 full life cycles, which would at best could go up to 8 or 9 years, vis-a-vis what your asset's life cycle would be. Having said that, I would like to just say that there are huge potential. The government is going to be talking about 40 gigawatts of solar rooftop, and I think you need to have behind the meter or after the meter, you need to have storage technologies. That's part one of the issue. The second part is there is a national electric vehicle mobility that has a mission that has been launched with nearly 13,600 crores as the kind of a program spread. You have around 6 to 7 million cars. You all need to have electric batteries and so on. Now, as Ashish had mentioned before on Intel, you've got to be understanding the story of Tesla. The Tesla is a story that is completely a game changer. They are setting up a factory in Nevada in partnership with Panasonic, setting up a gigawatt factory of a volume that is double the size of what has been the lithium ion sales all over the world last year. Their game plan is to have 50 gigawatt hour per year as a production by the year 2020, of which 35 gigawatt hours is only for the electric vehicles. 15 gigawatt hours is going to the Sun City, where they are also the equity holders. So that's, now when you look at that, and then we have to look at the business model, and then we have to look at the financing. The market in India is amazing. It is in excess of 30 gigawatts from now to the year 2020. If you look at the driver for this, I would categorize this as one is in terms of the renewables part, the wind and solar. Why do we need that? Because there is variability and the generation does not match with when the electrons are needed for the load. The second part is the diesel generator part, and there is an economic case. What is the economic case? Currently, okay, with the crude oil dropping, the cost of generation from a diesel at any partial could be ranging anywhere from 16 to 20 rupees per kilowatt hour. So there, if we are able to look at, and there had been in the previous session and others covered, if you could size an energy storage and make sure that the diesel generator runs on the full load and have control systems, you make a case. I know that companies like large corporates which are very, very high on the issue of quality and standards, like Toyota manufacturing plant in near Bangalore, a huge set of deal sets for having power reliability. Now one needs to be looking at, and they have been looking at, how they could be looking at energy storage for diesel replacement. That's the second category of market. Electric vehicles, we have already talked, there's a third one. The fourth one is in terms of your transmission and distribution capacity enhancement deference. Now, in that case, it is not the cost. The cost is of a new line, new distribution line is much cheaper, but energy storage is one that can meet you with the time, because the time it lays in getting the ROW issues and the line laying out is far more. And then issues on transmission distribution is also in terms of reliability. Now, all these things, the whole market and the business model is going to be working only when there is a regulatory push. Now, as long as there is not a regulatory push, and for different sectors, the regulatory, the kind of big hammer regulatory push is required is different. For a diesel generator, for that market to take off, you don't need such a big hammer. But for all others, you need a larger hammer. Now, I've just come across, I just wanted to read out, but I don't think there's enough time. I've just got this report that had come out in January of 2014 by DNV Garad that had been done in US, which had done a survey of all the utilities and all the vendors and associated people of what is the kind of requirement for distributed energy systems. And it is a great insight for doing that. What are the characteristics that initial pilot projects need to have? What the demonstration projects need to have? What have been the drivers? And how one should be looking to be able to scale up these things. The issue that has been recognized, and this is a report in January, in the US market, who have been dwelling on energy storage for the last 7-8 years, including the California Public Utility part, which has now come out with a great thing. It had not been an easy thing. For this country to be able to come aboard and to have business models, I think there is a lot amount of preparatory work that is required. Essentially, that we know the markets. Now that needs to be investigated to know what is the viable business model that is going to be there. Associated with that are two important things. And this is what is the government as an enabler need to do. Is one is to get this business models investigated. Second is to understand what is the regulatory push that is required, just enough, and have adequate standards. This January 24 report of US, which talks about investigating all things, talks about great mismatch of regulations of the grid codes in various places as one of the serious barriers of doing that. Now, when AES is trying to do, or Tesla is trying to push, or Solar City is trying to do, they are all facing these issues. In US market is no different from us. The states' regulations are just as different for the other states. What I'm trying to only say is that this is a momentous time, and I really congratulate the conference organizers to see that it's an opportune time. Now, if we are able to get into this particular space of energy storage, the applications are broadly in three kinds. One is the utility kind, where you need to have grid ancillary services and you need to be managing that. And one of the things that have been laid out already is the Green Corridor report. You have the renewable energy management centers. What is the renewable energy management centers to do? Can do without energy storage? Not much. Energy storage has to be the heart of the things together with the control. That is on the transmission and distribution type, on the ISO, Independent System Operators level. The second part is on the IPP, as you had written in your presentation. So when you look at AES as a wind farm independent investor in US, looking at lithium ion to look at and serving and making a business model, is because there has been a regulatory mandate of looking at grid frequency support or grid response. Now, in India, we have begun on that. April 2013, there was a staff discussion paper on grid ancillary services. CERC is now looking on finalizing that. Now, as soon as this grid ancillary services becomes viable, that talks about frequency support, which is largely the lithium-ion kind of batteries. Then it talks about voltage supports. It talks about black start. This talks about the flow batteries and the molten metal batteries kind of. Those become applicable. Rooftop, the government of India has started, and I think SECI is also very seriously looking at it, and the effort that SECI is doing is really appreciable. Those need to be streamlined. There needs to be a kind of a framework. I think that is a very critical part people must be looking at whether it makes financing. On the issue, on the issue about where does it make a sense for the renewables, see, one has to be very careful in understanding and very common sensible. Is that the energy storage is the costliest item right now. It has evolved the fastest cost performance thing that is happening. In fact, the IHS, the US-based research and consultancy firm, came out with a thing that today the energy storage industry is at the same situation as what the solar PV was in 2010. That is to say, the volume is going to be becoming 10 times from 2014 to 2018. Just as the solar PV industry happened from 2010 to 2014. Now, the way that we have to seize up the whole thing is to understand that there has to be an adequate effort in trying to see that the adequate frameworks are there for financing. Financing, I think, will definitely flow if there is a business case.
Correct. And we touched upon many different things. So just for the audience, so although we see a clear case for diesel replacement, when a storage provider goes to customers, the sort of risk that come up is the customer first thinks, what if my grid situation improves? Then what happens? Then I don't really need to use storage that much. So there is a need to convert that CapEx model of storage to OpEx, where right now they all install diesel generators because there is not big capital cost compared to energy storage, but there is a big operating cost. So there needs to be a proven case where storage can be competitive with that. And hopefully we throw this thing to audience, and there are many other risks. Coming to Pramod, who is very patiently here. So you have been part of disbursing funds to early startups. When I look at US as a market or Europe as a market, there is a good ecosystem of innovators. We have in the East Coast, Boston kind of places where there are small entrepreneurs. We obviously have Silicon Valley, and they have developed a process of how to support these entrepreneurs through universities, through DOE funding and all those. Can you throw some light on what you had been doing and how, for an entrepreneur, if I am developing a storage, how that works, and can that kind of model be replicated in India?
Well, let me quickly kind of just build upon what the last speaker spoke about regulatory issues which will make or break a particular project finance, and I'll quickly come back to what you asked me. And the reason for that is, besides SolarCity, there are pure storage companies such as STEM or Green Power Network who will actually use the high demand charges for customers as a savings option using storage. And it's energy saving, it's an energy service company contract. So over the last 10-15 years of life of the battery actually, they enter into a contract. So this is besides having solar online. Second thing, on the regulatory side, there's a merchant plant come up because the regulations have changed, and the last speaker spoke about that, such as flywheels and batteries in some East Coast areas where they are playing in the market. And lastly, California recently had project the requirement of 1,325 megawatts of power we bought from energy storage. Now, why that was beneficial was because there are many storage technologies which have taken the technology risk out. But however, just waiting for the businesses to be taken up, and that was the reason. So as a person who has been involved with developing various technologies, especially storage, over the years, many battery technologies, flywheels, capacitors. It's very graduating. It's very good to find that now there are business models existing which are allowing for these technologies to go into the market. Coming back to your question about, and I said at the opening of my statement, was that depending on what stage of technology development you are in, the funding options do vary. If you're very early stage, the agencies such as ARPA-E, which is Advanced Research Program Administration for Energy, it was offshoot of DARPA, which was for defense. So they fund very early stage technology at a federal level. And then there are agencies such as California Energy Commission, there are agencies such as New York Energy Research and Development Authority, which also fund. Now, only I mentioned these two because there are other smaller also, but in terms of sheer large amount of money which is available, it's that these are the agencies to fund that. But they do not fund technology for technology's sake. They have a public policy to implement, such as clean air, or such as getting rid of pollution, or less dependence on oil or gas, which is for sheer economic reasons. So these are the public policy drivers which decide which technologies to fund, and that's how photovoltaics and wind now storage is coming into place. A second thing is that often when we say research, we are not even talking only about physical development or engineering development. For example, I'll give a case study in just 2 minutes. In 2001 or 2003, I funded Beacon Flywheel, $1 million for frequency regulation. That was not enough. Yes, it worked. We had to go to the utility and install that particular flywheel on the transmission side to show can it respond to the frequency response or not. That was number 2. Number 3 was, having done that, can we model it to say, is it better as compared to other conventional options such as turbines? So can it ramp up 3 times, 4 times faster? That was number 4 stage, in which again research was involved, and Pacific National Lab, I think we had a contact with them to basically model how quickly, how fast does it ramp up, and what is the environmental benefit. Even that was not, the last stage was basically getting regulators to buy into it. This is a benefit to the grid. So coming back to what stage of development you are at, the kind of research development you need is totally keep on varying and depending on entities are. So that's the spectrum of that. And lastly, it just so happens that my colleague from Customized Energy Solutions was this Judy Jensen, who was involved with data to change the regulation at first level. We had to convince them. And I think her job was more difficult than developing technology. So this is the example of where you are in technology development, what challenge you are facing. So research and development is deployed not only for developing physical assets or capability characteristics, which is a necessary but not sufficient condition for getting the technology in the market. So there's all kinds of research and data and analysis needs to be done, and there are various agencies which do that.
So I think there is a clear message out of this conference about the policy framework, and that's one of the reasons Customized has this India Energy Storage Alliance and these kind of platforms to reach out to policymakers and regulators. But I want to leave the discussion a little bit separate because we have been discussing that in other sessions. Coming back to financing, excuse me. I was with a PE fund in US, and we had been approached by different companies who are at different stages of commercializing technologies, and they always used to say, well, for first couple of projects we'll get DOE grants or DOE funding or loan guarantees, and almost instantaneously we said no to these companies, mainly because we didn't really know how it works. But unlike their general perception, also reaching out to that kind of funding, even the funding is available already here also we have seen, but to reach out for smaller companies where funding is difficult, at least in my experience. How does that, is my experience correct? Because
that is true. The loan from DOE is a very crucial. We talked about, for example, when you product development is one thing, and product finance is one thing. Project development, project finance is totally different situation. You have to scale up with many millions, many megawatts, and $100 million situation. In which the technology is there, but the bankers don't take the technology risk. There is a market risk, and that's a crucial link in which Department of Energy steps in. Let me get back to Tesla. Tesla is the factory now. Tesla got $500 million of loan from DOE. And much to their credit, they paid it 3 years in advance. I was at the conference when Mr. Elon Musk announced that I want to give this check to the Secretary of Energy. That was a big thing. It's a political condition, football in the sense, a lot of parties say, don't give money to renewables or clean. But this was a good example. So they play a role in basically taking the early financing risk.
Yeah, so there are certain risks also regulators they have to take in India too, and other funding agencies like ERIDA. And there are many aspects that come to my mind, but I still want to throw it to audience before we go to lunch. We may have time for 2-3 questions.
Another viewpoint. If you look at on the other side, as to about the need for financing to be ready. Look at the case of Italy. In 2011, 9 gigawatts of solar PV was added, and the system could not take it because of the ramps and everything, and system was going to break down. Utility NL wanted to have a solution, and the only solution was energy storage. Now they battled for nearly 18 months before the projects could be happening, because there were investors, there were technology providers. It's because they could not find out, or they could not figure out who would own the energy storage. The ownership of the energy storage is pretty important. Who owns it? Who pays it? Or how do you get the revenue? And how is it regulated? Whether you talk about a distributed generation part in a bulk generation or at the end use, the important thing is about the ownership. So this market, in terms of financing, will easily flow.
Yeah.
This particular issue is there.
And there are established models for like solar projects and those, but they haven't really come into storage projects yet, even in US or other countries.
And just on the part of it, this is an absolutely scary situation, because today we are sitting at nearly 5-6% of renewable energy penetration in energy levels. We are moving with the accelerated way as the government currently is doing. By 2016-17, we will be reaching to the level of 11-12. By year 2019, we will be exceeding 15%. Now, this system, our Indian grid system, cannot take anything closer to 10% without a major shutdown if we are not having energy storage. So, energy storage is so goddamn essential for our renewable energy target for our energy security. And that is the speed with which we need to move, and I'm glad how City is looking at this sector.
Time for 2 questions. Can we get a mic here?
I'd like to go for another dimension, not only in euro sense or dollar sense. If you are going to compare gas turbine with energy storage system, there is another component the state should take care of, which is not in financial terms. First one is job opportunities. If you are going to systems, then every course is going to cost. Because in many places, like in my country, in Upper Egypt, every job opportunity costs 15,000 euro, because it will be a tourist. And you should offer them. And my students in the university, when they are graduates, and so many millions are jobless, then there is a social cost for job opportunities offered by energy storage system versus gas turbine. The second component, which MIT proposed in the Saudi Arabia program, technology transfer. If there is component added to the country of technology transfer and local manufacturing, then it should be considered. In many places, if you go for procurement and then it is local manufactured in India, you are allowed to get 15% more. This is also another source of money. So job opportunity, technology transfer, and even educating your people.
Yeah, and
capacity building.
Okay, so I mean, that's more common. So in many policies like solar or any other policy, when comes up, all these aspects are taken into account, and job creation has a lot more priority by government. Is there any other question? Can we go at the back?
Hi, John here. How do you bring in quality assurance? So if you're financing it for a longer term, you need to assure the quality is there. And with these new technologies coming out, how do you make sure that's coming in? Because we find, for example, that people give very poor solar home systems or solar lanterns, and they spoil the market. You can't finance, banks don't want to finance anymore. So how do you counteract those kind of issues with energy storage and new technology coming up?
So let me understand the questions. In rural areas, how do you finance these technologies?
Not just rural, as this new technology coming out, do we have quality assurance mechanisms coming in to make sure that the financing market is not being spoiled by perhaps bad examples of technology?
Okay, maybe you can mention some of that. But as he already mentioned that there is some funding available that storage project can tap into. We talked about mobility mission, so that has some funding available. There is a funding allocated for smart city. So I think it's a lot more structuring that you need so that you fit into that scheme. Is there anything
particular? Has launched many such policies for supporting such kind of things. For rooftop projects, they are giving 30% subsidies. For other also schemes also, they are giving support through NCA funding and other fundings. They have also launched a scheme wherein they are giving 40% subsidy through NABARD and NHB, and the appliances are to be bought by the customers through MNRE approved list of vendors, and then they can approach a bank. They will have to bring in 20% of the money from their pockets, and then rest of it can be funded by those banks. And the rate of interest is also very lucrative. That is around 5% for them, and thus they can buy the products and then pay later.
I thought the question was more related to quality.
Yeah, so you're providing these funding mechanisms, but how do you know you're funding the right projects? Because taking the examples that I'm familiar with is rural electrification. There are lots of projects funded by MNRE, mini-grid projects, which have failed.
Can I take it? Sure. See, essentially, I think when you're talking about energy storage, I think the Central Electricity Authority, and respective distribution utilities or the central utility part, they will have to come together to come out with the standards. Of course, the history is not so very fine, so we is in terms of implementation. So for the solar projects, when it is implemented, there is standard CEA guidelines for low voltage right through the amount of harmonics and quicksort. So driving it down into the states, because power is a concurrent subject, getting the distribution utilities in various states to comply with the CEA norms is a challenge that FECI and MNRE do face. But I think, as you have said about energy storage, there needs to also be standards in terms of quality, and I think it's not just in terms of power performance part of it, and also in terms of the environment, health and safety of the chemicals post the usage. So I think these will have to evolve as the program is being looked by the government.
So again, these are policy issues, and the recent power grid RFP, they also have given list of certifications that you have to qualify and put the project. And they looked at other international projects, what are the standards that they are following. So it's been there. So in terms of how it should be done, it's not very difficult. It's a matter of execution. But again, coming back to, I think we go towards policy issues a lot more. Coming back to one critical aspect of exchange rate risk, and maybe I'll take Ashish on that. What we have seen is there might be a cheaper international funding available, and which comes at very low interest rate, but of course it's in different currency. Now, the exchange rate risk that one can take. So there are not many investment banks who take such a long-term exchange rate risk. So such an institute in India is ERIDA. But the margin that they add on top of what they get loan for is tremendous. So if they get a loan at a 1%, 2% interest rate, I mean USD or any other currency, when they put their hedging cost in rupee terms, it suddenly again becomes 10% or 11%. And there is a reason for that. That is a bottleneck. Is there anything, any ministry or anything that is happening to tackle this issue, because that will become a critical issue?
Yeah, I think so. There's a lot of the problems over here is basically the hedging cost, which matters a lot. What happens to a 4%, 5% fund when it comes to India? It becomes 13, 14%, which is as good as any other bank loan which you can get in India. So this has been a case even for climate finance. Climate finance is basically all the countries in the world are trying to meet. I mean, presently they are all in Lima. There is a lot of conversations happening on how to finance clean energy projects, including energy storage in India and developing countries, and basically those nations which are affected by climate change. Climate finance is a huge subject. There is a lot of money which needs to flow in. The recent, announcement by the French embassy on $1 billion euros, which needs to come into India. And I was with the AFD, which is French development agency in India. I was talking to them, and the Ministry of Finance a person from Ministry of Finance was also there. This issue was raised, and I think there's a committee which is specifically looking at how to bring in climate finance into India without actually burdening the end users with the hedging costs. And probably in the next 2050 is when the Paris conference will happen, and when the entire world will come to some kind of understanding on where we all need to go, on what are the objectives we need to meet, what are the targets we need to meet to arrest climate change. But by mid of next year, probably the Ministry of Finance will come out with some guidance on how these will be reduced, and is there specific ways the hedging costs can be reduced. And I think we are very much near to get hold of a lot of climate finance which can flow into India.
Okay, so I think we realize we are in between lunch and you. So I thank all the audience for listening patiently, and let's give our panelists a big hand for
Thank you to all the speakers for this session. As a token of appreciation, can we please have the kids? Vinayak.